For today's lesson, we are doing a Unit 5 expressions review for day 1. Looking at our objective, it says, I will be able to understand how to use letters to represent numbers, evaluate algebraic expressions, and simplify algebraic expressions. These are some keywords that we want to keep in mind. For adding, there is plus, more than, increased, combined, and sum. To subtract, the keywords are deduct, less than, minus, take away, difference. Multiply, there's double, multiply by, product, times, factor, and group. And for divide, there is split, part, half, separated, per, and cut up. Looking at letters and to represent by numbers first, we have the sum of 15 and x, so sum of 15 and x. Well, the word sum means to add, so we want to add 15 and x together, which you can write it that way, or you can write it x plus 15. Looking at this one over on the second one, it says w less than 8. So w less than 8. Well, the key word here is less than, and that means to subtract. And we want to subtract 8 from, we want to do 8 minus w because we're trying to find out w less than 8. Looking on our next slide, it says the product of 5 and y. So the product means to multiply. And so we're trying to multiply 5 and y, which we can simplify this to be 5y. Looking on our last one for letters to represent numbers, it says split 8 by g. So we would split means to divide, and we want to divide 8 by g. Moving on to evaluating algebraic expressions, right up here it says 15x plus 5 when x equals 2. Well, we now know the value of our variable is 2. So instead of having 15x plus 5, we now have 15 times 2 plus 5. And we substitute the value of our variable right here. Now we can do 15 times 2, which equals 30, plus 5, which gives us the answer of 35. So our answer for our first one would be 35. Looking at our second one right over here, it says 4 plus 2y when y equals 6. Well, now we know the value of our variable is y, so instead of having 4 plus 2 times y, we now get 4 plus 2 times 6. And now we can multiply 2 times 6, which gives us 12, plus 4. 4 plus 12 gives us 16. So our answer for our second one is going to be 16. Go ahead and try the third one right down here on your own. It says 9w divided by 3 when w equals 4. You now know the value of our variable. Go ahead and stop the video and try this on your own. We'll come back and see if we have the same answer. So we now know that w equals 4. So instead of having 9 times w divided by 3, we now have 9 times 4 divided by 3. And we first need to multiply 9 times 4, which gives us the answer of 36, divided by 3, which gives us the answer of 12. So your answer should have came out as 12. Lastly, looking over here on the right-hand side, it says 5 times r divided by 5 minus 5 when r equals 6. If you want to go ahead and try this on your own and come back and we'll see if you have the same exact answer. So instead of having 5 times r divided by 5 minus 5, we will now have 5 times 6, because we now know the value of our variable, divided by 5 minus 5. Well, now we can do 5 times 6, which gives us the answer of 30, divided by 5 minus 5. And 30 divided by 5 gives us the answer of 6, minus 5 gives us the answer of 1. So your answer should have came out as 1. Moving on, we are going to work with simplifying algebraic expressions. Looking right over here at this top one, it says 2v plus 10 plus v plus 12. While working with simplifying algebraic expressions, we need to find like terms. We know that 2 times v plus v are like terms, and we know that positive 10 plus positive 12 are like terms. And now that we know that we have like terms, we can add them to one another. So now we get 2v plus v, and we get 10 plus 12. 2v plus v gives us 3v, and 10 plus 12 gives us 22. And since they're both positive, we would get an answer of 3v plus 22, or you can write it as 22 plus 3v. And that's our simplified algebraic expression. Looking at this next one, it says 2w plus 5w minus 5. Go ahead and stop the video and try this on your own and see if we'll come back and see if we have the same exact answer. So working with algebraic expressions, we always need to find like terms first. Well, we know that 2w plus 5w are like terms, and we know that negative 5 is its own like term. So knowing this information, we can add our two like terms to one another, which would be 2w plus 5w, because this middle operation was adding. So 2w plus 5w gives us the answer of 7w. And we had this last term, which was a negative 5, so we have to continue with that. So your answer should have came out as 7w minus 5 for our simplified algebraic expression. Looking at our next one, it says we have 22x plus x plus 2x. So when working with algebraic expressions, we always need to find like terms first. So we know that 22x is a like term to positive x plus positive 2x. So they're all like terms, so we first need to work left to right. So 2x plus x, we add together, so 22x plus x, we get 23x. Oops. And then we have that last term, so 23x plus 2x, which gives us the answer of 25x. So your simplified algebraic expression should have been 25x. Moving on, we have 9s plus 12 minus 8s minus 11. If you want to go ahead and stop the video and try this on your own, we'll come back and see if the same exact answer. So if we need to first find our like terms, if we know that 9s is a like term to negative 8s, and then we have positive 12 is a like term to negative 11. So looking at these, we need to add or subtract like terms, whichever the operation is. So for 9s, 8s has a negative sign in front of it, so it's going to be minus 8s, which 9s minus 8s gives us the answer of s. And then we have positive 12, and this was let me erase it so we can see it a little better. It was a negative 11. So when we subtract 12 from 11, we get 1. So our final simplified algebraic expression should be s minus 1. Lastly, we are trying to figure out whether these expressions are equivalent or not. So we want to first combine like terms right over here on this right-hand side. So we get 2c plus 10c, which when we combine those, we get 12c. Another way that you can do it, which we have learned about that you can only do when trying to find equivalent expressions, is you can substitute any value in for the variable. So we're going to say that c equals 2. So we'll do 12 times 2, and then we would have 2 times 2 plus 10 times 2. So we're going to work out this one right here first. So 2 times 2 gives us 4, plus 10 times 2 gives us 20, and 4 plus 20 gives us 24, and then 12 times 2 gives us 24. And since they both are the same answer, they are equivalent expressions. So yes, they are.